Hello, and welcome to this edition of Lake News 22. I'm your host, Ryan Peterson. Today, we're going to be taking an in-depth look at iMachining. Joining me today is Ken Merritt. Ken is the Director of Partner Projects and Senior Application Engineer at SolidCAM. Recognized as one of the best application engineers in CAM, Ken brings high-end technical capability, product innovation, as well as exceptional training and support skills. As a CNC trainer and product manager, and having extensive knowledge of how technology is best leveraged in the workplace, Ken has an incredible background and skill set aimed at making SolidCAM customers more successful and more profitable. Hey Ken, thanks for joining us today. I hope I didn't embarrass you with that introduction.
That's okay. Thank you, Ryan, and I just hope I can live up to it.
Can you give us a brief explanation of iMachining, what it is, what it does, and how it is different from other high-speed toolpaths?
Our company, SolidCAM, has developed a toolpath strategy that maximizes material removal rates while increasing the tool life dramatically, ensuring that the cutter and the spindle are always at a constant and comfortable load and never overloaded. You see, iMachining always runs at a very consistent efficiency throughout the entire toolpath. The user can actually choose how aggressively they want it to run the cutter, and iMachining will ensure that the cutter and the spindle are always running free of any unnecessary stresses. This gives our customers amazingly fast cutting through even some of the hardest materials, along with surprisingly great tool life and good surface finish. iMachining, I think, really best represents who SolidCAM is as a company. We're devoted to assisting our customers become much more productive and profitable.
You just mentioned never overloading the spindle. Can you explain that in a little bit more detail?
A traditional tool path tends to load up the tool through chip compaction. That really just means that the chips can't get out of the way and they keep getting recut. Also, in many areas of the cut, the tool can be overworked, corners and things like that, for instance, trying to clear out too much material. This causes higher forces and temperatures on the tool and actually decreases the material removal rate. It can also cause unnecessary vibration dynamics that can damage the tool and the CNC machine spindle. And SolidCAM's iMachining is always managing the minimum and maximum cutting angle in concert with the cutting edge velocity and, of course, the chip thickness as well. And that ensures that the tool interacts with the material in a way that the forces on the tool and the spindle are perfectly balanced, resulting in pretty constant loads and no spikes.
I've heard from other CAM software companies that they have the same thing or similar. What makes iMachining unique and different from the claims of other CAM systems?
Well, iMachining is very unique. To start with, we have several patented technologies that control the toolpath and the cutting parameters. And these are technologies that nobody else has. We hold the intellectual property rights to our morphing spiral algorithm that maximizes the tool and material contact and really optimizes the balance between material removal and repositioning of the tool. iMachining actually manages variable cutting angles to support morphing spiral's approach to very complex geometric shapes. We modulate the feed rate appropriately to maintain constant chip thickness as the cutting angle changes during morphing. See, iMachining manages the balance between the morph spiral and the D-slot trochoidal toolpath motion, which maximizes morph spirals to improve the efficiency in unusual shape relationships.
That's pretty impressive. Some of the claims from others appear to say that they do that, or at least something similar. They talk about constant chip load. Isn't that the same thing?
Despite the claims of other systems like volume mill, dynamic mill, adaptive roughing, profit milling, and others, they generally only control the constant step over and a constant chip load, which actually means that the chip thickness is continuously varying. And this is evidenced by the constant changing sound of their cut and the inconsistent shape and color of their chips. You see, there's a big difference between chip load and chip thickness. Nothing else, and I mean nothing else, has the consistent smoothness of an iMachining toolpath. iMachining is very specifically controlling the chip thickness at the actual cutting angle. Others are just controlling the chip load per flute per revolution at the front of the tool. It's really not the same thing. Their technology results in a continuously varying spindle load, which means that the forces on the cutter and the spindle are very unstable. You can really hear this when you listen to their cut compared to an iMachining cut. Even though we're always cutting 20 to 30% faster than they are, you really have to experience iMachining to begin to understand how powerful it is.
So as a machinist in the real world, what would I experience that would be different if I was to use iMachining?
This is usually extreme disbelief and fear, okay, about breaking tools, running the machines so fast. But once they get over that fear and they experience the incredible smoothness of running at the true maximum material removal rate, they really quickly get addicted to iMachining. Now, there's also a couple of other things that will be immediately obvious. First, the sound that I mentioned earlier. It will be surprisingly consistent anytime that the cutter is engaged in the material. Second, and this is really important, the spindle load meter is also going to be very shockingly low, surprisingly low, and stable throughout the entire cut, with a very gradual and predictable rise as the cutter begins to wear. And so this is one of the real visual differences that you can really see at the machine. A lot of serious machinists like to lean against the machine. This gives them an opportunity to really sense how the cutter is working. They get to feel the vibration and immediately sense any strain or stress that's occurring during the cycle. With iMachining, it's incredible how smooth it is. It's actually kind of fun watching expert machinists experience this for the first time. The look of amazement on their faces really tells a fantastic story as they hear, the sweet music of iMachining, the music of making money.
iMachining claims to remove the material much faster and make the tool last much longer. Aren't those opposites? If you're cutting more aggressively, shouldn't that wear the tool out sooner?
Great question. It doesn't really make sense until you understand the physics behind it. By doing all the things that we just discussed in iMachining, the angle of the force vector is extremely stable and at the best angle possible to protect the carbide substrate of the tool. This means that the most delicate part of the flute, the sharp edge, only sees compressive force. It never sees tensile force. And it doesn't start microchipping until much later in the life cycle. And that microchipping that does start also progresses much slower. And so the tool lasts much longer. See, carbide is extremely hard and resistant to abrasives, but as most people know, it's also very brittle. If you apply tensile force to it, it doesn't take much to fracture the substrate. So, as we just explained, iMachining completely avoids the tensile forces.
That all sounds pretty technical. Any way you could explain that in a little bit more basic terms?
Sure. It all boils down to keeping the cutting tool in the optimal conditions throughout the entire cut. Imagine, if you will, if a machinist was able to adjust every factor of the cut in real time to instantaneously handle all the varying geometry so that the tool only sees a very constant load, basically keeping it in the sweet spot where the cutter performance is at maximum. The tool will last much longer, even though we're at elevated performance levels, because it's not going to be shocked by vibration or impact or temperature spikes. With iMachining, we increase the material removal rate at the same time that we're reducing these destructive forces that apply to the cutter. The result is less damage to the cutter over a longer period of time. Now, what's really cool is during that time, we have a much better material removal rate. So the stock is removed faster and the tool lasts significantly longer.
Pretty impressive. So, what are real everyday advantages to the user?
Well, let me tell a little bit of a story about that. We have a longtime customer that was very unclear about iMachining, and they were asking us what type of CNC machine they needed to buy to begin cutting stainless steel. You see, they had been making aluminum aftermarket automotive performance parts for quite a few years. but they were using an older, kind of lower powered CNC mill. And we told them that their existing mill would be fine to cut stainless steel if they use iMachining. It took us a little bit of time to convince them, and they created a whole new stainless product line without having to buy a new machine. Now, we have hundreds of success stories like this from our customers. They're up on our website, www.solidcam.com. We have another success story about a customer cutting Inconel so quickly and with such great tool life that he was afraid his competition was going to hear about it. He was so grateful that after a while, he couldn't stop talking about it. And he ended up giving us a fantastic success story.
That's awesome. So from the user's point of view, how much different is it programming in iMachining? It has all that great power, but how easy is it really to program in iMachining?
Well, although iMachining is very unique and powerful, for the user, programming is much easier and faster. There are a lot of things that we do better in iMachining than what we see in other CAM systems. For example, since we're fully integrated in your SolidWorks and Inventor CAD systems, and we have feature recognition, iMachining 2D CAD geometry selection is really just pick and go. We have automatic stock recognition, so we rarely have to build containment geometry, and that saves a bunch of time when you're programming. Also, iMachining 2D supports all steps, including roughing, rest roughing, and finishing of prismatic parts. With iMachining 3D, even complex mold cavity and core can generally be roughed in a single toolpath. Even rest material operations with smaller tools can be set up in the same interface with automatic stock update. Again, no need to create complex containment geometries and things like that, like they do in other systems. One example, I guess, of a customer's experience, they actually were having to create, I think he said something like 20 plus toolpaths. Wow. With multiple containment boundaries, and it took them several hours, and they were using a product called Volume Mill to rough their part out. With SolidCAM's iMachining 3D, they were able to rough machine that same part with a single iMachining 3D operation and no need for boundary containment. So their programming time actually went from several hours down to like 20 minutes.
That's impressive. That all sounds pretty interesting. Isn't it challenging to figure out all the right cutting angles, feeds, and speeds and depths of a cut to make all this work? Especially with all the different materials any shop may be having to use?
Actually, that's one of the best advantages and true strengths of iMachining. The iMachining wizard recognizes the capabilities of the machine, the properties of the material, and the characteristics of the cutter, and automatically calculates the best cutting parameters to take advantage of that information to keep the tool cutting at the most optimum conditions. All that the user really has to do is specify their desired performance setting, giving them full control of the cut while iMachining figures out all the details. The wizard has a very powerful patented algorithm to use all of that material, tool, and CNC properties information to compute the necessary cutting parameters to ensure that the cut is managed properly throughout all the motion necessary to machine the part.
Wow, that all sounds awesome. So how long would it take the average company to recoup their investment in iMachining?
That may be one of the best questions of the day. Obviously, it depends on the type of work that the shop's doing, but many times it can happen in as little as a single project. Generally, if a customer is doing a lot of bulk material removal, they're going to see a great ROI almost immediately, really within the first few projects.
Well, thank you, Ken. That was really an interesting explanation of iMachining. To find out more, where would people go to get more information?
Well, one of the best ways is to log on to our website, www.solidcam.com. There are tons of amazing videos and stories about customer successes with iMachining, and there are several hundred customer reviews that you can check out. There's also links to how to connect with us via phone, email, chat. The best thing you can do is really connect with us and give us the opportunity to work with you so that you can actually experience the iMachining phenomenon.
That sounds great. I also understand that there's a forum that gives you kind of a sneak peek behind the scenes at SolidCAM. That's forum.solidcam.com, right?
Yes, there really is. In fact, it's kind of unique in this industry because it is sort of a look under the hood into, the company of SolidCAM. SolidCAM's founder and CEO, Emil Somak, truly believes in being transparent with our customers. The forum is a place where you can go to read about all kinds of different things going on inside the company and with the software. Future growth of the software with projects that we're planning and such. You can even see sometimes in there some pretty tough questions, okay? And we do our best to answer them. And it's really a very open community.
That's all really interesting, Ken. I really appreciate you taking the time to explain iMachining to us today.
Well, thank you, Ryan, for having me here on today. It really is an opportunity to get the word out about iMachining, and we appreciate it.
Thank you, Ken. If you have any questions, please check out solidcam.com and their forum at forum.solidcam.com to see what iMachining can do for you. Well, that wraps up this edition of Lake News 22. I'm your host, Ryan Peterson. We'll see you next time.